Welcome to Graphing Rational Functions and Their Graphs, Part 2. All right, so here we're going to graph this function, f of x equals x cubed divided by x squared minus 4. All right, this one will have a slant asymptote because we see that the degree of the numerator is 3 because we have x cubed. The degree of the denominator is 2 because we have x squared. And 3 is 1 more than 2. So that gives us a slant asymptote. Now always you want to factor first, right? Because you don't want to assume there's a slant asymptote and then have a factor cancel and have a very different graph. All right, so we can factor the denominator. You can either use factor by grouping, as I have on the right hand side. What multiplies to give, so 1 times -4 is -4. It multiplies to give -4. Adds to give us the b term of 0 would be 2 and -2. We can also just recognize that this is a difference of squares, right? So x squared is a perfect square and 4 is a perfect square, and there's a subtraction sign that makes that a difference of squares. So when we factor a difference of squares, it's just square root minus square root plus square root. So the square root of x squared is x, the square root of 4 is 2, and the same factor except change the sign. All right, so either way I'm fine on that factoring. And when we look, we see we have nothing that will cancel out between the numerator and denominator. So that leaves us 2 vertical asymptotes. All right, all we have to do is set the factors equal to 0 and solve for x. If x minus 2 is equal to 0, add 2 to both sides, x is 2. If x plus 2 equals 0, subtract 2 from both sides, x is -2. So now we're going to find the slant asymptote, and we have to find this using long division. We cannot use synthetic division because our divisor is not just x plus or minus a constant, it's an x squared. So if we're dividing by x squared, if we're dividing by x where we have a coefficient, right, then we're going to use long division, but otherwise you can use synthetic. Right, so whether this is long division or synthetic division, you need to make sure that every term is represented. So in the numerator, we have an x cubed. So that means I need an x squared, an x, and a constant. But we don't have an x squared, an x, and a constant. So if you're missing any terms, represent them with a coefficient of 0. So here we have x cubed plus 0x squared plus 0x plus 0. That's true whether we're doing synthetic long division or synthetic division. Our divisor is also missing a term. We have an x squared, but notice we have no x. Right? So that means we need to represent that x with a 0 coefficient. So we rewrite x squared minus 4 as x squared plus 0x minus 4. All right, so now we can begin long division. So when we're dividing using long division, we ask ourselves, what would we have to multiply the leading term by to get the leading term of the number we're dividing into, the dividend? All right, so what would I have to multiply x squared by to get x cubed? All right, I have to multiply by x. Right, x times x squared would give us x cubed. All right, so now I multiply every term by x. So x squared times x is x cubed. X times 0x is 0x squared. -4 times x is -4x. And then we subtract, which means to add the opposite. All right, change everyone's sign. We have to, when we're subtracting all the terms. We have to remember to distribute that negative and change all of the signs. So x cubed minus x cubed is 0. 0x squared minus 0x squared is 0. 0x plus 4x is 4x, and we can bring down the next term. But if we look, we have an x squared here, and we can't divide an x squared into a 4x. Right? So this here is our remainder. And we can't do any more dividing because what we're left with here is a smaller degree than what our divisor is. Right? So your divisor has to at least be the same degree. So because the x squared canceled out and we don't have any x squareds, I can't do any more dividing. So that means the slant asymptote is y equals x. Nice, easy slant asymptote there. Right? We don't care about the remainder. Right? We're just going to use the part that went in evenly. All right, so now we want to find our x-intercepts. So to find the x-intercepts, set the numerator equal to 0 and solve for x. All right, so if I set x cubed equal to 0, we can take a cube root of both sides. Cube root of x cubed is x, cube root of 0 is 0. So we have, this is the x-intercept, and it happens to be the y-intercept, the point 0, 0. Right? So that is one of our points. Because we have two vertical asymptotes, we need at least 6 more. We need one on either side and between vertical asymptotes. And we want 2 or 3. And it's going to depend on what our graph looks like. Right? If it's clear with 2, we can use 2. Sometimes we're going to want 3. And we'll determine the domain and range on the other page. All right, so let's find some points and start graphing. And the first thing we're going to graph is the vertical and slant asymptote. And I did graph the slant asymptote already. I kind of forgot I had it graphed. And so it's certainly easy enough. This is actually the second time I've made this video. That's why this is up here. And it took me way too long just to get it in the right spot. Because you see, every time I fix one side, the other side gets messed up. That doesn't look too bad now. Only took me like 27 tries. So our slant asymptote, and this is in your notes, right? So by the way, make sure you wrote down this part, which is just the long division. That was the only thing really to write down, right? And a little bit about that our x-intercept is also our y-intercept. All right, and so now we're going to graph the point 0, 0. We have that point. And that is, so to graph our slant asymptote, we're going to graph the point 0, 0, right? Because our slant asymptote is the equation y equals x. All right, so that means it has a y-intercept of 0 and a slope of 1, right? So this is just applying to our slant asymptote. And then, well, 0, 0 is also a point on our graph, but we'll talk about that in a moment. So the y-intercept for the slant asymptote is 0, 0, and the slope is 1. So you just graph the point 0, 0, and then you can just go up 1 to the right 1, up 1 to the right 1, and get more points. And you can also go down 1 to the left 1, down 1 to the left 1, and so forth to get more points. All right, whatever you need to be able to graph the line y equals x. So this is the slant asymptote. Let's graph the vertical asymptote. So we have 2 and negative 2. So our slant asymptote is going to go through our point, our x-intercept, is going to go through our slant asymptote. The only time we'll cross a slant asymptote, just like a horizontal asymptote, is when we have 2 vertical asymptotes in between those 2 vertical asymptotes. Right, when we're really close to 0, we might cross the horizontal asymptote or the slant asymptote. But as x gets larger and larger, we are not going to cross that slant asymptote again. All right, so now we need some points. So let's graph some points on either side. We need to graph some points that are less than negative 2. All right, and I'm actually going to use 3 points because on this graph, 2 points might not be clear enough, and you'll see why. All right, so let's use, I think I did negative 5, negative 4, and negative 3. All right, so negative 5 gives us negative 5 cubed divided by negative 5 squared minus 4. That's going to be negative 125. And then 25 minus 4 is 21. All right, so now if that had been, so it's actually just a little bit more, a little less than 6. Just 1/21 less than 6. Because if that had, or negative 6, if that had been negative 126, right, then that would have actually been 6. So we're very close to 6. If we plug in -4, we have -4 cubed divided by -4 squared minus 4. That's going to be -64, and this would be 16 minus 4, so that's 12. That does reduce, and it would be a good idea for us to reduce that. Oh, you know, actually 125 21st reduces. No, it doesn't. I take that back. For a second there, I thought it reduced, but it does not. But 64 twelfths does reduce. They're both divisible by 4. So this would be -16 thirds. All right, so that's -5 1/3. So a little bit less. And then -3 would be -3 cubed divided by -3 squared minus 4. That would be -27. That'd be 9 minus 4, so that'd be 5. All right, and so that's -5 2/5. So that's actually a little bit more. So of these three, this is the smallest point, the -16 thirds, because that's a third is less than 2/5. Right? A third is 0.33, 2/5 is 0.4. So it's just a little bit. It's the smallest. All right, and now let's graph 3 points in between. We always need 3 in between to know what our graph is doing. In between vertical asymptotes, and our perfect one would be -1, 0, and 1. Of course, we know 0 is 0. But let's look at -1. So we have -1 cubed divided by -1 squared minus 4. That's going to give us -1, and that would be 1 minus 4, so that's -3. So that's going to be positive 1/3. If we plug in 1, we have 1 cubed divided by 1 squared minus 4. Well, that's just going to be the same thing, but this time it's going to be negative, because in the denominator we have 1 minus 4. So we have 1 over a -3. That's going to be negative. All right, let's see if we can get everybody in here. If we plug in 3, we have 3 cubed divided by 3 squared minus 4, and that's going to be 27/5, the exact same thing. And you know what? We're going to get, if we plug in 4, we're going to get positive 16 thirds. If we plug in 5, we're going to get positive 125 21st, right? Because the only thing it doesn't really matter whether I square a positive number or a negative number. I'm going to get the same thing. So the denominator isn't changing. And only the numerator is changing. If I cube a negative number, it's negative. If I cube a positive number, it's positive. So we can kind of see the pattern here. And if you're all right, we're just gonna write in the answers here. We can maybe squeeze them in. So 16 thirds, and just squeeze it in here. 5, 125, 21st. And they can move it up just a tiny bit. The 0 doesn't need that much space. All right, so let's graph our points and see what kind of shape this is. All right, so on the side here, we have, all right, so that was really, really, really close to -6. And we plugged in -5, so really close to -6, just a smidge less than that. So notice we are below the 5, -6. Yeah, we are below the slant asymptote, and so we are not going to be where it's kind of going on the outside of that. I don't know. To me, it reminds me of an X pattern between the vertical asymptote and the slant asymptote. We're not going to be on the outside of that. We're going to be nestled inside the arms of the X there. So we kind of see an X there, kind of nestled in those arms of the X. So there's 1 point, and then we have -5 1/3. So that's the smallest of the points. So like right there. And then -27/5 is a little bit more. And if you're ever not sure, use a calculator and get a decimal equivalent. All right, so you see how it's turning around again. So it's not going to cross the the slant. It's not going to cross the vertical. It's just going to be nestled in between. And I did not do the greatest job of going through those points. There we go, that looks much better. All right, so we should go through the points that we found. and then we would head towards the asymptote. And if you have 3 points, that's going to be a little bit more accurate to graph than just 2 points. Now let's graph the center part. So we have -1, +1/3, 0, 0, right where our slant asymptote is, and then 1, -1/3. Now do you see how they're like in a diagonal? Right? So that if they're in a diagonal, that means that this shape in between the two vertical asymptotes is an S. All right, and it gets closer to the vertical asymptote, but it doesn't cross. And it just crosses that slant asymptote at 0, 0. All right, there's our S shape, and we can see our points are all graphed there. All right, so now let's graph the last 3 points. So 3/27. So that's 5 and 2/5. So it's almost a half. And then 5 1/3 is a little less. And then we have almost 6. Now you see we have that kind of the U-y shape, if you will, where it turns back around. Because it's not going to cross, once it crossed it in the center, but it's not, our graph is not going to cross that slant asymptote again. It has to turn around. So this is that other shape we can have, just kind of nestled in between the x's there. For the domain, just take out your vertical asymptote. So -∞ to -2, -2 to 2, 2 to infinity. Just so you see how we're just skipping over the 2 vertical asymptotes. So everything until we get to -2 is great, and then oops, jump over -2 because that would be undefined. If we plug -2, we'll have 0 in the denominator, and then everything is great until we get to 2. Jump over 2, right? Because that would be 0 in the denominator, and then everything greater than 2 is fine. Right? The range you can see from the graph here. Now, if we looked at the 2 parts in the x's, right, the range is kind of unique because we had a big gap there. But because of the part in the middle there, our range has got everything covered. So -∞ to infinity is going to be the range. Right? And then one last thing. Let's do the end behavior. We haven't done end behavior in a while. All right. So we're going to have end behavior as x gets larger and larger, or smaller and smaller, and at the asymptotes. All right, so f of x, so as x approaches -∞, notice our graph is going down. So as x gets smaller, so is y. So f of x approaches -∞, as x approaches -∞. Then we get to the asymptote, and notice that as we approach -2 from the left-hand side, our function is approaching -∞. So f of x approaches -∞ as x approaches -2 from the left. But if we're coming from the right-hand side, right, then the graph's approaching infinity. So f of x approaches infinity as x approaches -2 from the right. All right, so now let's look at 2. All right, so as we're approaching from the left, right, f of x is approaching -∞. So f of x approaches -∞ as x approaches 2 from the left. And then as we approach from the right, our graph is approaching infinity. So f of x approaches infinity as x approaches 2 from the right. And then as x gets larger and larger, so is the function. So f of x approaches infinity as x approaches infinity. Okay? So the graph gets smaller and smaller as x gets smaller and smaller, larger and larger as x gets larger and larger. And then we can see what happens at the asymptotes. I'm just going to get rid of all those little arrows. They were just there to kind of point things out to you. All right, and that's the end of this graph. All right, so I just did 3 with the slant asymptote. The only one I didn't do is where we didn't have the center part, right, where we were missing the center part. maybe I might do a short review on that, just so you know what to do for domain and range when your graph has a gap. But for now, this graph is done. Have a great day. Thanks for watching. Bye for now.